Okay guys, welcome to my trivia number 004, a balanced WYE-DELTA circuit, a positive sequence ABC. I'm going to discuss or share with you the basic relationships of the line current IL and the line voltage VL with respect to the phase voltage BP and the current IP in a balanced WYE-DELTA circuit. Here on my right side here is the phasor diagram, and on my left side here is the WYE-DELTA circuit balance load configuration with a phase sequence A positive ABC. And this is the VAB here, the line voltage CV here, which is equal to the VAB and the phase voltage of the delta load. And this relationship with the line voltage VAB here is leading the phase voltage phase shift angle, the VAN here, by plus 30 degrees phase shift angle, and the magnitude of the VAB here is greater by the square root of 3 VAN plus 30 degrees phase shift angle. So you just have to be reminded that this equation here, equation 1, will be the basic rule in applying when we have this WYE-DELTA balance load here. Okay, next, let's go to the next one. Okay, what we have here is we have the line current here. We are asked to find the line current here, which is equal to the line IB, current IB, and the line IC, which are feeding the delta load here. And okay, now the line relationship with the line current IA here is lagging the phase current by negative 30 degrees phase shift angle. But its magnitude here, this magnitude of the IA here, is greater by the square root of 3 IAB minus 30 degrees phase shift angle. So we have to be reminded also on this second equation here. This is also the basic basics and standard rule when we are dealing with this WYE-DELTA balance load here. And at the same time here, the IAB here, the equations of the IAB here, this one is equal to the VAB in this one divided by the delta impedance here. And also at the same time, this can also be related to the IAB is equals to the line voltage of the VAB and the Y source and the Y generator here divided by the impedance and the delta load. So let's go to the exercise, the applications of this equation 1, the equation 2. Okay, we have a given here VAN here. We have the VAN here, which is equal to 200 as a 35 degrees phase angle, and this is the delta impedance, which is 15 plus J8, and we are asked to find the line voltage VAB here or the VAB here, and also find the phase current IAB. This is phase current here, and also the IBC here, and also the ICA here, and also you have to find also the line current IA, IB, and the IC, which are feeding this delta load circuit here. So let's go to the calculation procedure number 1. As you can see, find for the VAB of the Y generator based on the equation. We have the equation here. Equation 1 is the square root of 3, the VAN, the phase angle plus 30 degrees, and we already have the VAN, and this is the VAN here, 200 times square root of 3 and the phase angle is 25 plus 30 degrees, and so we have this value 346.455 degree phase angle. So we have to substitute this phase angle here, this in this equation here. So VAB, we have the VAB 346.4 with a phase angle of 55 degrees C divided by the delta impedance here. This is the VAB here divided by the delta impedance, that is the IAB, and at the same time we can also have the IAB by this VAB here divided by the impedance in this delta load. It's all the same, and we have this value here. So if you want to get the IBC, you just have to, this is the magnitude here. The magnitudes are all the same because it's a balanced load. And if you want to get the IBC, you just have to minus 120 degrees phase angle, IEC 240, and there you go, you have all these things. Now the calculation procedure number 2 is by using the equation 2IA, which is equal to the square root of 3 the IAB here, and you just need to substitute this one, and by substituting this we can get this IA 22. We have this IA 22.10 negative 3.0 phase angle, and so on and so forth. You can find the IBC, IB, and the IC. So that's all, folks. Thank you for watching. Subscribe and share, and all stay safe always. Bye.